Hi everyone, welcome to the third edition of Acoustic's webinar. Today's webinar will be dedicated to acoustic calibration
Hi everyone,
services.
welcome to the
During
third
the
edition
webinar,
of
we will
Acoustic's
focus
webinar
on different types
Today's
of calibration.
webinar will be dedicated
How they are
to
performed.
acoustic calibration.
Hi everyone,
role
welcome
in
to
Dewesoft
the
method
during the
edition
webinar
of
we will
Acoustic's
focus
webinar.
on different types of
Today's
calibration.
webinar will be dedicated
How they are
to
performed.
acoustic calibration.
Hi everyone,
role
welcome
in
to
Dewesoft
the
method
during the
edition
webinar
of
we will
Acoustic's
focus
webinar.
on different types
First
of
and foremost,
we shall begin by establishing the meaning
Hi
of
everyone,
calibration.
welcome to the
During the
focus
webinar
on
we will
this
focus
webinar.
on different types
First
of
and foremost, we shall begin by establishing the meaning of
Hi everyone,
calibration.
during the webinar we will focus on different types of
First and foremost, we shall begin by establishing the meaning of
Hi everyone,
calibration.
during the webinar we will focus on different types
First
of
and foremost, we shall begin by establishing the meaning of
Hi everyone,
calibration.
during the webinar we will focus on different types
First
of
and foremost, we shall begin by establishing the meaning of
Hi everyone,
calibration.
during the webinar we will focus on different types
First
of
and foremost, we shall.
Okay, here we go. Dzwoni звук в смысле еще.
Okay. Okay, I apologize for a bit of disturbance. We have some technical issues and we will resume shortly. So like we said, each calibration instrument, each measurement instrument must be calibrated in order to know that the readings of the instruments are indeed true. So consequently, because of this fact, calibration represents a fundamental step in the process of measuring. And why is that so, one might ask himself? Because actually calibration ensures that your instrument accurately indicates the required measurement parameter and also that it's performing to specification. In essence, calibration checks the accuracy of your instrument and also determines the traceability of your measurement. But why do we even perform calibrations? Acoustic measurement procedures are heavily regulated by standards, for example, ISO standards. In order to ensure the comparability and repeatability of obtained measurement results. Inside these standards, additional requirements for standardized calibration of utilized measurement equipment are stated. These calibration of equipment are carried out in an accredited laboratory according to international IEC standards. Example of most common IEC calibrations include calibration of measurement chain as class 1 level meter and calibration of octave and fractional octave filters. Both of those calibrations we will focus a little bit more later on. By calibrating the equipment accordingly and following the ISO standards for measurement procedure, obtained results can then be used for official ratings of equipment. For example, when we issue ratings for sound power for certain machinery or equipment. But generally speaking, calibration should be performed in the following situations. When we acquire a new instrument that has not been utilized before, for example, and after each repair or modification that has been carried out on the measurement equipment, in the event of specified time period or specified usage in operating hours having elapsed. Furthermore, it's a good idea to carry out calibration before and after a critical measurement in order to ensure that characteristics of the system remain the same during that critical measurement. And a thing that influences the measurement system very much are different types of events, some of them also unwanted events. For example, exposure to a shock, vibration, or physical damage, or change in environmental conditions. In both of those cases, calibration should be performed. And performing a calibration is also sensible whenever the performance of our measurement instruments appear questionable or indications do not match the surrogate instruments. But most oftenly, the calibration frequency is dictated by different specific requirements, such as customer specification or instrument manufacturer recommendation for calibration intervals. As we have established the meaning and importance of performing the calibration itself, let's focus next on particular calibration procedures and their corresponding standards. We will begin with one of the most widely used and performed calibration services, which is Class 1 SLM calibration of our entire measurement chain according to IEC 61672. When it comes to sound level meters, IEC 61672 is actually the most widely used standard to perform the calibration. Procedures for calibration include tolerances and are designed to verify that the characteristics of the sound level meter in question are indeed correct. Some examples of the test characteristics include frequency response of microphone and filter, the time weightings, for example, fast or slow, level linearity, overrange indication, and many other parameters. Generally speaking, sound level meters are divided into different classes of accuracy, where Class 1 is intended for procedure measurements and Class 2 for simple measurements. Approximate accuracy for a sound level meter of Class 1 is 1 dB and 2 dB for Class 2, meaning the accuracy requirements for the SLM to pass the calibration process are different for Class 1 and Class 2. And of course, Dewesoft data acquisition systems can be calibrated using the procedure for Class 1 SLM in accordance with the IEC 61672. Most suitable DAC slice for the job is our dual core series, as it covers a wide dynamic range of 160 dB. Alright, next in range of widely used and often required and performed calibrations is calibration of octave and fractional octave filters according to IEC 61260. For this kind of calibration, periodic tests of octave band and fractional octave band filters, whether as dedicated instruments, built-in sound level meters, or other measurement solutions, such as for measuring sound power or intensity, are performed according to standard IEC 61260. When measuring the spectral contents of sound, the signal is divided into frequency bands with a constant relative bandwidth. Constant relative bandwidth, or shortly CPB, means that the width of the band is proportional to the center frequency of the band. Constant relative bandwidth is most often used in either whole octave or 1/3 octave bands. So these are also the two most often calibrated CPBs. And actually very similar to the standard for SLM, also in the IEC 61260, two classes of accuracy are stated for the octave filters. Class 1 and Class 2, of course Class 1 being effectively better as it is more accurate. Now we have learned about the calibration procedure for the SLM and for the octave filters. But before performing the actual measurement, microphones used for the measurements should be calibrated for level by utilizing an acoustic calibrator. In order for this level calibration to be effective and true at all, we need to be sure that the output of calibrator we are using is spot on. For this reason, calibration of the calibrator itself is performed according to IEC 60942. The IEC 60942 standard defines three classes of accuracy: LS, Class 1 and Class 2. Class LS is intended for laboratory use, only, while class 1 and 2 are intended for field use. Calibration of the calibrator itself is performed at a single frequency, either 250 or 1000 Hz, and at supported acoustic pressure levels. Usually those levels are either 94, 104 or 114 dB. Calibration is performed by performing the comparison method using a reference piston phone as the standard comparative sound pressure level. The report for calibration of a level calibrator includes measurement of sound pressure level, frequency, and total distortion. If the instrument is equipped with an accessory barometer, this is checked at the current air pressure. In addition to before mentioned calibration of complete measurement chain, which would include microphone, cables, data acquisition unit, and software, meaning the SLM plugin, all of those can be calibrated as class 1 SLM, but also separate calibration of the measurement microphone alone is often presumed. Calibration of all types of microphones is performed according to IAC 61094 with or without amplifiers. The sensitivity of the microphone being calibrated is measured by comparison with the reference microphone. The two microphones are exposed to the same sound pressure in an active comparison coupler, which contains a built-in sound source. The measurement frequency can be set to either 250 Hz or 1000 Hz. The measured sensitivity is valid at the environmental conditions during the measurement. Corrections are of course made for the influence of environmental pressure, temperature, and humidity on the reference microphone. In addition to measuring the sensitivity of the microphones, we also determine the frequency response by using an electrostatic actuator, which can be seen on the picture. This is a widely used tool that can simulate a constant sound pressure on the diaphragm of the microphone over a wide frequency range. The actuator measurement is a relative measurement, and the results are normalized at the sensitivity measurement frequency, which is also called the reference frequency and is either 250 Hz or 1000 Hz. Depending on the type and application of the microphone, free field or diffuse field corrections may be added to achieve the required type of frequency response. So all of the calibration services that we have seen so far are often used for either when we want to measure with an SLM, when we want to measure sound power through sound pressure level, but of course, if we want to measure intensity, some sort of specific calibration for sound intensity probe is also required. So the specific IAC standard for calibration of intensity probe is IAC 61043. Let's take a look at how this is performed and why it is important and perhaps different than other types of calibrations. Sound intensity is generally measured with sets of pressure sensing microphones. A set consists of two microphones with phase characteristics which are essentially equal, so they need to be as closely phase matched as possible. A very close match is necessary as even a small phase response difference may cause significant errors of the measured intensity. Consequently, sound intensity probe calibration is very important for having accurate and true results. And the calibration consists of sensitivity and phase check. The sensitivity of the microphone pair being calibrated is measured by comparison with the reference microphone, actually the same as in IAC 61094. But in addition to sensitivity measurement and phase check, the pressure residual intensity index for the complete system is also calibrated in accordance with the demands stated in IAC 61043. So in this short webinar session, we got to know the fundamentals of particular acoustic calibration procedure, and let's now focus also a little bit on the strengths of performing these calibrations with Dewesoft. Some of you might already know that as a measurement solution provider, we are committed to simplifying the measurement world for the user. As we dedicate a lot of effort into providing complete measurement solutions, we are very proud to say we support all of the today's stated calibration services, enabling our customers to have a complete system upon delivery. This way they will save precious resources and time and are able to start measuring right away. In order to achieve this, we paid special attention to our customer needs when shaping our calibration services. To ensure the best possible execution and worldwide standard compliance, we partnered up with an experienced, internationally accredited calibration laboratory. As a result of this partnership, we are able to provide a highly competitive service featuring worldwide valid calibrations to traceable international standards, 5 working days turnaround time, state-of-the-art calibration management system tailored to the user. This way the user gets notified when calibration is about to expire and calibration process can be tracked while being performed. We support digitally signed certificates, which are easily accessible from anywhere via included link. And perhaps most importantly, our partner lab has more than 35 years of experience in sound and vibration measurement equipment service, ensuring the highest possible quality of execution. All right, this was a brief overview of calibration services and how they are performed with Dewesoft. I would like to thank you for your attention, and remember, for the right results, calibrate with Dewesoft in order to be absolutely sure you measure correctly. The Q&A section will follow shortly. Feel free to pose any questions and ask for additional information. I will be very glad to help you. Thank you everybody for joining us today and have a great day. Bye bye.